Algebra 1 students, we are looking at part 5 of lesson 1.1, and we are going to use problem 4, using words for an expression. This is so easy, and there's just so many possibilities on this. Okay, so let's look at this. We have 3x. Well, what does 3x really mean? It means 3 times a number x. So in words, we could say it's 3 times a number x. We could also say it's the product of 3 and a number x. I do not care how you write these out in words, just so long as the fact that the operation that you have going on meets the words and the setting of it does. Okay, so I don't care which one you use. If you use the first one, congratulations. If you use the bottom one, congratulations. They're the exact same thing. They're just worded differently. Okay, so again, I don't care. I don't care which way you are to write this out on your homework. Either one is totally fine. Okay, so let's look at the next one. 10x plus 9. Well, what's the operation going on between 10 and x? Good, it's multiplication, so we could use product of. We could use tons of things. What is happening? What else is happening? We're adding 9, aren't we? So again, we could come up with multiple ways on this. You can say it's 9 more than the product of 10 and x. Or you can simply say, hey, 10 times x plus 9. There you go. Again, it doesn't matter. It really doesn't matter, as long as you have everything under control with the wording matching the operations. Okay, so go ahead and try this one out. Try out x plus... Just try that one out, because if I say it, then I'm going to give away the answer. So go ahead and pause the video and try that one out for me. Awesome. If you would have said x plus 81, or the sum of x and 81, or 81 more than x, there's tons and tons of ways of doing this. It doesn't mean they're wrong. It just means there's different answers to these, okay? Try out this one. And yeah, just try it out, because if I say it out loud, I'm going to give you the answer. Okay, so when you stopped the video and you looked at this one, what did you come up with? Well, I came up with the quotient of n and 3, or even n divided by 3. And if you would have came up with something differently on this one, please go ahead and make sure you're correct, so you know you're correct or not. Whether it's raising your hand or waiting to get back there with me and discuss your homework from the previous night. Okay, try this one out. Try that one out. Go ahead and pause the video and try that one out. Write in words the algebraic expression. Okay, so assuming you pause the video and you work this one out, you could have quite a bit on here. You can have the product of 5 and x minus 1. Product means timesing, doesn't it? It means multiplication. Or you could simply say 1 less than the product of 5 and x. Well, doesn't that less than mean what it's coming from the 5 and the x? Yeah. So it's going to be match up to here. That's all that matters. All my words match up to here. Questions on writing expressions? Okay. So now we have a little situation. We have a word problem. And I pulled this word problem straight from your book. So if you need time to write it out, to go for it. Here's our thing. We're showing the height above the floor of a house of cards. It depends on the number of levels. What is a rule for the height? Give the rule in words and as an algebraic expression. So if we look at this, there's a really cool picture in your book that goes along with this. It says the table height is 24 inches. The cards are 3.5 inches tall. So in your book, it tells you, hey, look, we got levels of 2, 3, 4, and now we're looking for the n. N just means any level. It means any number. It can mean 1,000. It can mean 10. It could mean whatever it means. It's kind of like it's kind of like a variable that's always here. Or how can I put this? It's going to be your variable. It's going to be the variable that changes. The amount of cards I put on the table is going to change. The height is going to change. The levels are going to change. So therefore, that's where the n comes in. I really hope I didn't confuse you, and I did. Please let me know. So what would our words be? Well, what are we doing up here? We're taking 3.5 times 2, adding 24. 3.5 times 3, adding 24. 3.5 times 4, adding 24. Does that look familiar? Yeah, so what do you think is going to happen down here? Where am I going to plug that in at? I'm going to plug that in at the 4. This is going to be 3.5n plus 24. If I look down here in an algebraic expression, we got 3.5n plus 24. In words, what do? We simply multiplied 3.5, the levels by 3.5. And then we added 24 to it in order to come up with our algebraic expression. Okay, let's look at another one. This is one of my favorite ones because it has a little bit of geometry in it. If I look at this, I have polygons, and you can read the question straight out of your book if you want to. Polygons. Polygons just means many-sided shapes, or many sides. Poly meaning many. So in this one, I have a rectangle, and it says to draw triangles from one vertex. Vertex are the corners. Okay, vertex are the corners of the shapes. So here is a 4-sided polygon, and I drew one line through it, and therefore I have 2 triangles. Well, if I look at this one is a pentagon. It's a pentagon because I have 5-sided figures, 1, 2, 3, 4, 5. And if I draw a circle, or sorry, if I draw a line from the vertex, 2 lines from, I'm going to get 3 circles, or 3, wow! I'm going to get 3 triangles. Let's try this one again. I'm going to get 3 triangles. So what is happening here? This is a 5-sided figure. This is a 5-sided figure. 5-sided polygon. But I only get 3 triangles out of it. This was a 4-sided. But I only got 2 triangles out of it. Okay, well, what's 4 minus 2? 2. What's 5 minus 3? 2. That's pretty nice, spiffy. What about here? This is a 6-sided figure. It's called a hexagon. If I were to draw triangles, draw lines out of it from the vertex, I'm going to come up with 1, 2, 3, 4 triangles. Well, what was happening? Good. I hope you realized that I was subtracting 2 from each side. So we have the number of triangle, or the number of sides of a polygon, and that varies, right? I could have a 15-sided figure. I could have a 10-sided figure. If I were to draw triangles from one of their vertexes, I would come up with a number of triangles. If I would draw lines from the number of from a vertex of the polygon, I will come up with a certain amount of triangles, and it's always going to be 2 less than the number of sides. So if I look here, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4. So what would my algebraic expression be? Good. I hope you guys said it would be n minus 2, because n is the number of sides of the polygon. And what is happening here? We're subtracting 2 from the number of sides of the polygon. So that's the words. This would be the algebraic expression. Okay. Go ahead and try this one out. It's the bicycle one. It's the bicycle one. So go ahead and try out this one. It says, while on vacation, you rent a bicycle. You pay $9 for each hour you use it. It costs $5 to rent a helmet while you use the bicycle. Write the rule in words and as an algebraic expression. Those are definitions. That is our deal. We also have given a nice little chart that says if I write it for 1 hour, it's going to be 9 times 1 plus 5. If I write it for 2, 9 times 2 plus 5. Write it for 3, 9 times 3 plus 5. Notice the 5 staying the same, the 9 staying the same, but what's changing? Good, it's the part that is being multiplied by 9. So we could write this out as n 9n plus 5. I can also write it in words because I want it in words. 5 more than the product of 9 and a number. Multiple different ways. Again, when it comes to your homework assignment, we'll check it out. We'll make sure that we're consistent. And that ends actually all of lesson 1.1. Thanks, Algebra 1.